Well, as Casey said, I'm Stacy Adams with the University of Nebraska Department of Agronomy and Horticulture. My primary purpose in this project was to help Sandy Patton select a site and develop this particular high tunnel that she's going to use. Now, Sandy had already picked something that she thought she would like to have. Her application is unique because it's for a perennial fruit crop, which was something that Casey and I thought was quite fascinating on this. We came up a year ago and cold weather had set in pretty severely, and she had been using irrigation or overhead sprinklers to try and prevent her fruit crop from getting frozen. So what was there, about an inch? I had pictures of an inch of ice on her fruit.
Every berry, every branch.
Raspberry pop.
So she actually, this is going to be a project that's going to be interesting to watch here for the next few years because there's two things. One, she has a long production season potential here, and the longer she can get more fruit off, then the more profit that she can get. Also, given the type of management strategies, she could potentially cut some of the crop back and make her crop even last longer. So you could have an early season crop from the previous year's wood. You're the specialist in this, but as we were discussing it, it gave her the opportunity to sell more product throughout the whole year. So that was fascinating on that. The potential for this crop is to get very tall. So that's why she selected a fairly large high tunnel. This one's got 6-foot sidewalls on it. Is it 40 feet wide? Is that what you have? 30 feet wide, and she's 60 foot long on this particular house, and she's building a new house. What's that, about 72?
72.
Yeah, so she's got a 72-foot house going up next door here. For this particular project, it was somewhat budget directed on the size that she ended up with, because as I always talk about, the bigger the high tunnel, sometimes the better, but she was trying to work within a particular budget. We did know with this particular project that she needed to elevate the height of it, but we also knew for this particular site, which you can tell is quite windy, we had a lot of exposure issues. One of the key things that we were looking at was the wind coming from the south-southwest, so we built the houses in such a way that we could work with the wind rather than buffeting or catching the wind on it. You'll notice that her superstructure, when you look at it, is much stronger than what a normal high tunnel would be. She had an option of using just a pipe structure, or this is actually a really super strong structure that she wanted for some durability on it. If you look in there, you'll see there's quite a bit of cable bracing. I haven't seen the specs on this, but the minimum structure that's even rated is a 70-mile-an-hour wind structure, and I suspicion this is a 90-mile-an-hour wind plus, because you can see all the cabling Xing in there. Another critical factor is you'll notice that the sidewalls, which is different than most high tunnels, this has additional struts on the side, or knee bracing we call it, which will prevent that structure from pushing back and forth on there. I'm working with another grower right now that's put up a high tunnel, purchased it through the same company, and we have to know what we're doing, one, when we're constructing it, and two, when we're buying it, that their unit was missing wind braces. They didn't even have the plastic on it yet. They got hit by wind just on the end, and it pushed it a foot forward. So the contractor that did this particular structure did a nice job. If you have any questions about it, you can see not only do we have the cable bracing, but you'll see at each corner there's also a 45-degree angle in there that prevents that structure from moving north to south. Additionally, they're tied into either the hip board on the wall or to the purlins. And I think that's critical because we have to transfer that energy that's being pushed by the wind to prevent that from bending those posts. She has roll-up sides on this, and once again, this crop, 6 foot, 8 foot tall maybe. So she has these roll-up sides on either way that she can crank it up. She can determine how much wind she wants to let through there, and if she doesn't want very much, she can leave the sidewalls down. And she put large doors on this one, and she's putting a little bit smaller door on the other one there. So we'll see how the movement of air through there, but that's another reason we put this on a north-south direction, is that the crop in the middle could potentially get too hot. and we didn't want to delay flowering on it. So we wanted her to be able to open the doors up during the day. So even though it gets cold at night, she can open it during the day, allow the temperatures when they're hot on the inside to cool by letting the wind blow through it. So she can get the air to go through the crop too. So there was several things we were looking at on it. Not to mention the crop itself. So the sun typically is going to go from east to west. So when the sun's coming over, then she gets more crop uniformity, because you can see the way she has her crop spacing, that at any given time those plants will eventually all get light on all sides of it. So that will also improve the productivity for this particular application on it. This is a very large structure, so you put concrete piers under each of the posts on it. So this one's not really going to go anywhere. It's like concrete boots in there. It's going to. We're not worried about the structure sinking. We're more worried about lift, especially those of you that drove through the wind today. So those concrete boots are going to hold it in there. So we have it held down to the ground, and then we additionally also have all that wind bracing to keep the structure from moving around.
And that's actually the posts go into the cement.
Okay. So yeah, she's got the post going right into the ground, and the concrete has been poured around it. And I think additionally, didn't you guys run a hole through there and put a bolt in there so that those steel wall posts won't lift through the concrete? So they become a part of the concrete. We put some bolts in there. Would you put a couple bolts in maybe?
I just remember right.
Yeah, there's like 2 bolts in there that extend, and that way the concrete is actually held onto the ends of the post. You've got a 2.5-inch steel or 2 3/4-inch steel wall post. Something like that. Usually the largest most high tunnels will have is around a 2-inch steel, so this was even more exceptional on that. If you look at the bows overhead, they're at 6-foot spacing, but that is the multiple type of bow that's on there. It's an interesting bow because if you look at it, it has a channel on either side. If water catches on it, it should go on and follow down on the channel. Now the purlin application on this one's a little bit different, but this is basically a superstructure for a regular greenhouse, so she can modify it and turn it into a heated greenhouse later if she wanted. She has a single sheet of poly on it. You probably picked a fairly hot day because it looks like you have a pretty tight roof on it.
It's been pretty, pretty good.
Yeah, so you'll notice a key feature to any high tunnel is to get the plastic on the roof as tight as possible. And I've done them for a number of years. I know I'm a professor, but I have 28 years of practice just being a greenhouse person myself. I always learn that you pick the hottest day of the year to put your plastic on, because you get it as tight as you can then, but when the weather cools down, plastic shrinks when it gets cool, and that's how you get it so tight. We don't want that thing flapping up and down or any more than it has to, because it will reduce the structural integrity of the plastic. For those of you that don't know, many of you might know, we don't use just regular construction plastic on these. You have to use a greenhouse polyethylene film that's got a UV protection in it that keeps it from degrading. Did you use any additional resins in yours? Does it have like anti-fog or anything like that? Okay. They offer the cheapest plastic you want to use, or most affordable plastic, if you will, or economical, would be a greenhouse poly. Typically lasts 4 or 5 years. It's 6 mil thick, UV stable, and that's what allows it to last that long. From that, you can buy additional plastic resins that are put into the plastic. One of them is an anti-condensate. So you can see she's got some moisture developing on the inside. If she used an anti-condensate product, that would prevent that moisture accumulation. What it does is, one, it allows more light to come in because you don't get that fogging in there. But secondly, when she has this thing closed up, if she has a crop growing, that moisture dropping in there potentially could increase the diseases. You have to trade it off, find out whether it's worth your money to do it or not. But that's one product you can have. Another one is a infrared heat sheet, they call it. It's got some resins that are put in there to prevent for long wave radiation from leaving your greenhouse. That's only important at night because plastic is not a good insulator of temperature going through it. Casey Foster and I were just laughing about that on the way up. He said in his garden last year, I think he wanted to prevent his crop from freezing in his back garden. He should have used a sheet instead of using plastic over it. And he said, I think it froze it worse. And that's typical of plastic. Plastic is a horrible conductor, insulator. So that's why greenhouses typically have 2 layers of plastic, because it's the dead airspace that's giving us the insulation. It's not the plastic itself. One way the greenhouse industry has improved that by adding that resin, which prevents that long wave radiation from leaving your unit during the night. However, we're talking about $100, $150 a roll difference in price. So you have to kind of throw that back and forth. While we're still on the covering, you'll notice they have on the ends here, we have a polycarbonate twin wall, maybe an 8mm twin wall polycarbonate sheet. Now they were just discussing originally when this was installed, you see they have the wood framing. They just put the polyethylene right on it, and they used wood lath that was screwed to it.
Yes.
And it lasted 30 days each. The problem is there was no ability for that plastic to hold taut. The wind would get to popping it and it'd work it up through there. Now when I first started in the industry a long time ago, that's how we used to put poly on, and we would roll the poly on it so it went on the lath, and we'd have to roll 2 or 3 times, then we'd screw it in. It's very time consuming. The quickest way, best way to put it on is to go on and use the base channel with the spring lock or wiggle wire they call in order to hold that on. Since their house is so large, they've decided to just put the polycarbonate sheet on there, which has helped give you some additional strength against that north and south wind on there. So take a look at that. Also look on the roll-up sidewalls. You see these wood corners, and what those are is a skirt, if you will, to prevent air from catching in behind the roll-up walls. If you've ever been to the University of Nebraska high tunnels, which we put up a long time ago, we didn't put those baffles in, and the wind would catch the corner and lift your sidewalls up and blow them up, which was a problem. They've since, in the industry, have developed these side baffles to prevent the wind from getting in there. But you can see here that they built their own, and it works great. You'll notice on the other side over here where they have the drive bar that goes up, it's just a couple 2x4s. Additionally, you could put that, it's like
Back skirting on an RV.
yes, back skirting of an RV. You can put 2 of those brushes, if you will, together, and you can run it up through the brushes.
We found one alongside the highway, so we picked it up.
There. But the ultimate goal is, the whole reason we have a high tunnel is we want to absorb the heat during the day. We're banking the heat in the soil, and then at night we want to close it up, and we're hoping to hold the heat inside the structure. So what we want to do is reduce the air infiltration, is what we call it, when the air can sneak in from these different places. So the more Sandy can prevent that air from coming in, then the longer she can keep the temperature warmer, which means later in the season potentially more crop productivity. Does anybody have any questions for me specifically? Because I'd like Sandy to come up and talk, because this is her sweat of labor here. And it didn't blow away in the tornado. Yeah.
Is it worthwhile to put a second layer of poly over it to get an air gap?
The question was whether if I recommend 2 layers of poly. For most applications, not really, because your production typically is going to be what, March to November. So when we put a second layer of plastic, not only is the poly not a good conductor or insulator of heat loss, it's also not a good, it's not as clear as it visually you think it is. If you look in there, you'll see it's shaded. It's only about a 78% translucent, so when the sun comes through, you lose around, what, 22% of the light maybe coming in. If you put a second sheet on, then you lost another 20%. So then we start getting into our crop stretching, perhaps. The only time I'd really recommend maybe the 2 layers is if we were going to potentially heat it during November, December, January in there. That's just me.
That means you would probably have to have electricity.
Right. Yeah. That's true. You'd have to have electricity. Yep.
Another question, is it worthwhile to put in passive solar or some other type of heat system?
They were talking about banking the heat, and there's a lot of ways we can bank the heat. And I've seen several grants, and I've seen other projects where they're doing it. Anything is better than nothing. The problem is when the sun goes down, the heat loss is tremendous quickly. Anybody that already has a greenhouse knows that. You're standing there, it feels chilly all of a sudden. Anything we can do to hold that heat in, the better off we can. So some of the ideas have been using barrels with water. However, I wouldn't get too exhaustive in how we're going to do that, like using lots of pumps and different things, because the problem is it's the transfer of energy that's really slow. So the plastic loses temperature quickly, but to get the heat from the bank location into the atmosphere is painfully slow trying to get it out there. So what you're going to do is you're going to suppress the lows is what you're going to do with it. So it could add another week or two just because your lows won't ever get that cold. Do you see what I'm saying? But I wouldn't think they're going to get enough heat to improve your crop productivity. Vaughn, do you have anything to say?
If you're looking at doing something like that, then you start considering thermal blankets. If you're looking to contain
Yes.
the heat that's radiating from the ground itself. So, but then again, it's a cost consideration. But if you're trying to extend your season, you know, you're looking at some pretty decent prices, or, you know, extend your season on either end, spring or fall. So that would be the only thing that I would say would be a thermal blanket.
And I'm glad Vaughn's an extension educator down at Nebraska City. I'm glad you brought that up because I forgot one thing is one thermal blankets, but another one is an interior cloche.
Right.
So you can put another tunnel on the inside of a tunnel. So this is a big house. Maybe she wants to grow something over. She can put a smaller tunnel on the inside. And there's a grower over near Omaha that we saw that's running about 11 months of the year with no heat, and he's just using a combination of thermal blankets and those interior cloches. So anything we can do to hold that banked heat in the soil.
You have to choose your crops on that.
Yeah, it's not for everyone.
Do you like the north-south orientation, or do you like the east-west? For things like tomatoes, cucumbers.
Right, when you read on the internet, they a lot of times say it at our coordinates that we should have our houses east to west. Typically, I don't know, Dawn and I might fight on this, but I always go north and south because of this wind itself. Not to mention when you put your crop in there, it grows this way, and when you have a light going over, and I teach some science classes at UNL, we only need an hour, hour and a half of full sun on any part of the tissue to be enough to get the energy that we need to create that, what we call source sink relationship. So if we can get the light somewhere on the plant throughout the whole day, productivity is going to be better. So my recommendation would be to put it in a north-south whenever we can. However, if you ever look at any projects that I've done in the past, like I had one over at Creighton University, you'll see I put a greenhouse on the north side of a building. So you have to understand your given situation and what you have to work with. It did mean the pads had to elevate, you see, a lot of soil, because just a little grade difference meant a lot of dirt had to be moved into position. So, you know, if we were talking a huge steep hill, then maybe we would do the other. But then what we run into is, one, we catch the wind, and two, in the winter we catch all that snow and everything. And I was from southeastern Kansas before I came here, and I had a greenhouse down there, east to west, and the crops grew crooked. It was the strangest thing, and it just the way they are. The sun would hit the plastic, and the plants would just turn. May not a problem for this type of crop. For me, as a floriculturist trying to sell chrysanthemums, everything is green. So, you know, that's my experience. Did you have a question here?
What about hailstones?
Hailstones, excellent question. And what about straw from when they cut
And what about
wheat?
the debris from the tornado? Did you
The
see
debris.
that?
Excellent questions, all those. I'm glad you brought that up. That's where the tautness of the plastic is critical. If we can get that tautness, it's like a trampoline. So if we can get some spring or bounce in there where it can't absorb it, like a pillow would absorb it, that's when we start getting holes and stuff. So that's one of the recommendations, not only why we want to put the plastic on when it's hot, we want to make it taut so it doesn't flap, but then when we get this severe weather, we can also repel most of it. The plastic, it's pretty amazing. If you've ever gotten a piece of 6 mil plastic, you cannot stick your fingers through it without a lot of work. Usually when it's hot is when it's its softest. But that gets back to that resins. Remember me talking about all the resins you can add? Every time we add a resin to a 6 mil plastic, the softer it gets. So that's why Stacy always recommends putting the cheap plastic on the outside of the house, because it's going to actually be the strongest plastic, and putting your cheap, higher quality sheet, your heat sheets, your anti-condensates on the inside, because it's a softer plastic. So that's kind of one of those trade-offs on there. Did that answer your question? Anybody else?
Can I add something on the north, south, east, west?
Yes.
The cost that it takes with labor and replacing the plastic, so the product itself and all your labor, timing and all that, far outweighs the little bit of loss where we're located on the change in growth and production given the east, west, north, south. So I'm in agreement with Stacy, north, south, because for me, I don't want to have to maintain this any more than possible, right?
Exactly.
Your job is to make money growing stuff, not fixing stuff. So if you're spending a roll of plastic on here, $400, $500, $600, $700, whatever it costs, and then getting a crew out here to do it, cleaning it up, disposal, all that stuff, it's not worth doing anything but north-south.
Anybody else have any questions for me?
I'd also like to add, growers receive $4,600 to use their season extension practice. I think every grower that we picked has far exceeded that amount, but that at least gave them a kickstart to do this. To also give you a little bit more background, Stacy and I started this project a couple of years ago, and we sent out applications to about 51 growers, or about 500 growers. We got 51 applications that came in. We picked Sandy's because of fruit production, as also because of what she built. We also picked a couple of other folks that did a high tunnel similar to this down in Heber, Nebraska, for fruits and vegetables. And then also we picked one out in Elm Creek where he did a shade structure. We picked 3 more folks as well for this next upcoming year that we'll announce later on, but I just wanted to add that in before I forgot.